Okay, so now the question comes here. Through the resistor 5 ohm, a current of 1 ampere is flowing. Okay, through the resistor 5 ohm, okay, a current 1 ampere is flowing. Fine. Now first, okay, we will come one after the other. What is the current through the other two resistors? Clear? Find out, means we have to find out the current through the other two resistors, right? Okay. So first, see, means we have R1, R2 and R3. Okay, so you know, we here my total potential difference is not given, so we will solve it part by part. So first, from here we have, since we have the resistance and we have here the current, so what I will do is, before going to the questions, I will find out the relevant data that we can get. Okay. Okay, so if we say R1 is equal to, oh sorry, it's R3. R1 equals to, R3 equals to 5 ohm. Clear? So how much is R3? R3 is equals to 5 ohm. Clear? And if you see, this is series, right? This is series, that means current is coming. So here we can say that I3, let's say I3 is 1 ampere. We know in series it's same, but since it's not connected yet and ending, just for time being, let me write I3 equals to 1 ampere. Fine. Now we know as soon as my I3, that is 1 ampere, comes here, it splits. So that means in R1 and R2 my current will be different. Clear? That means that, but the I3 is the total current that is coming. That means if I say I3 equals to I1 and I2, will it be wrong? Definitely not. Why? Because I3 means it's coming 1 ampere. So 1 ampere is getting splitted up into this two, that is I1 and I2. So that means after I3, that means I3, that means it's the summation of I1 and I2 only. Clear? Okay. In this circuit, I am talking about in this circuit. Fine? Okay. We don't know anything about the current. Okay, can't help then. Then what we can do is, from here, since we know here the total current is this much, first let me find out the equivalent resistance. Clear? First let me find out the equivalent resistance. Now equivalent resistance of the parallel circuit will be 1 by 10 plus 1 by 15. So it will be 6 by 30. Fine. My 1 by Req. Now let me just reciprocal that. So Req is equals to 5. Clear? So Req will be how much? It will be 5. It will be 5 ohm. Clear? That means overall the resistance of this is 5 ohm. So parallel circuit resistance will be how much? 5 ohm. Clear? Okay. Now this much is done. Okay. So since we have the overall resistance as 5 ohm, if the overall resistance of the circuit is 5 ohm and my current total is coming 1, then we can easily find out the voltage. Okay. So voltage is equals to IR. My overall resistance is, overall current means how much current, total current is how much it's coming, 1, and overall resistance is how much, 5. That means it's 5 volts. Clear? That means 5 voltage is at this point, not at this point. Remember, because here my voltage is how much? Here my voltage is wait, just a second. Here also I'll calculate the voltage here. This is I3 R3. That is total 5 volts. Okay. Have I done anything wrong here? Yeah, I've done something wrong. See. How comes it? How is it coming to here? Just a second. My addition was wrong. Hence, this is also wrong. Okay. So here my LCM is 30, 10, 3, and here it will be 2. So that means 5 by 30, 5, 1, and 5 here 6. So now that means my equivalent resistance will be 6 ohm. Clear? We just need to reciprocal them. So that means 6 ohm. Fine. So the equivalent resistance will be not 5. It will be 6 ohm. Clear? That means for this circuit my overall resistance is 6 ohm, current is 1. So my voltage will be 6 volts. Fine. So that, and here also we did not solve. We had solved this. That is, here my voltage is how much? 5 volts, and here my, in the total voltage it will be my 6 volts. So if that means we have 5 volts and we have total 6 volts, that means together we have how much volts? We have 11 volts. Clear? This is just this normal, data that I'm trying to extract. Okay. Next, that means here in parallel my voltage states here how much? 6 volt. Clear? Okay. Now let us go one by one. Anything else missing? Yeah, we can also find out how much current is going through 10 ohm and 15 ohm specifically. Okay, so through 10 ohm, okay, if I want to find out the current, that means it's V by R. So V is how much? Overall resistance is how much? 6. After all, in parallel, we know what is the overall resistance is the specific the voltage across each resistor is equal to the overall voltage, and for series the overall current is the current that is passing through each resistor. So that means here the total overall voltage that we have in parallel, that is 6 volt, correct? That means, what is it? Just a second. Yeah, so 6 volt, and specific, that means 10 resistance we have, that means 0.6 ampere. Fine. So that means 0.6 ampere is flowing through here. Okay, I'll just put a green here. That is 0.6 ampere is flowing. Now, from this answer, no, we can find out in 2 different ways what is the current in R2. Okay, so we know that this is, that means, what did I find here? I found out here I1. So we know that I3 is equals to I1 plus I2. So I3 is how much? 1. I1 is how much? 0.6. That means I2 will be 0.4, right? 0.4 ampere. Oh, I was about to write ohm. 0.4 ampere, correct? But there's another way also how you can find. Let me see. That means just a similar way I will find out I2. I2 is equal to voltage by R2. Now what is my voltage? Definitely 6. And what is my specific resistance? That is 15. 3 2s are 6, 3 5s are 15. So that means 0.4 ampere. Is it correct? Fine. So that means the overall, that means we have found out the specific current to R1 also. Okay, first let me see what is the question. What is the current through the other 2 resistors? We have found out, that means if you say we know what is the current that is going from 5 ohm. So I2 is 0.4. Okay, so I2, okay, so one is 0.4 ampere. So one is 0.4 ampere, other one is 0.6 ampere, fine. So that means my first question is done. What is the potential difference across AB? So across my AB is this potential difference. This is my potential difference across AB V3, because after all this is only my VAB. Clear? Next, what is the potential difference across AC? A and C. Now this is something we will do. Okay, what is the total resistance of the circuit? Have I not done this? No, I have not done this. Okay, so I'll just see how can we do. So these 2 questions, that is across AB we have found out, right? So number 2, that is VAB is equals to I3 and R3, which is 5 into 1, that's 5 volts. This is done already. Clear? Next 3, what is the potential difference across AC? So VAC is equals to VAB plus VBC. Clear? VAB is how much? 5. And how much is VBC? Now VBC is what? The voltage that we have already found out. It is 6 volts, right? Because we know after all the voltage will be same. That is 6. That means we have already found out that in 11 volts, right? Let me show you how. See, this is how I have found out, but this is just for my general knowledge I have found out. That means total 11 volts is already done. Last, what is the total resistance? Yes, this is something that we have not done. So my total resistance here, my resistance is how much? 5 ohm. and here my resistance total means my total parallel resistance will be how much? We have calculated 1 by 10 and 1 by 15, no, in the previous slide. How much? Where is it? Yeah, so R equivalent resistance is 6. So I will just add here 6 ohm. Now these two are in series, so it's total 11 ohm. Clear? So all of the 3 questions are done. Clear? This is how you have to solve. Make sure this, this seems as if there's a huge kind of complex. Maybe it may seem so, but after all, it's not. Okay, just you need to keep this thing in mind. We know that in series current is same. Why? Because each and every electron everyone is seeing, just like the train stations. Okay, each and every station sees the same number of bogies of the train. And in case for parallel combination, what is happening? The struggle that we route through the different routes is independent of each other, right? So that means whatever the voltage we do, or whatever the watt potential is there, after all it depends on the overall voltage only. Hence in parallel my voltage is same, but since my current gets splitted up, hence my current is not same in parallel. Clear? Okay. Thank you guys for watching this video. If you really find this videos informative and helpful, please do subscribe my channel Vigyan Joki, hit the like button and share it with your dear and near ones. And yes, please don't forget to comment, because your feedback does matter.